we finally made it to the HR diagram, right? We talked about this in the crash course, or at least Dr. Phil talked about it in the crash course. This is just crazy. Okay, so it starts off fairly simple. You have luminosity and surface temperature, right? Surface temperature also going to color, right? And that's how they plot it. Not a big deal. They put the sun in the middle because, okay, luminosity, it's in solar units, so where else is the sun going to be, right? In the middle. Now, temperature, it just happens to fall almost in the middle too. Okay. Now, if you just plot a few of them, you're not really seeing much. However, a lot more, you can start to see a pattern. Okay, and this kind of blacked out line, that is what we call the main sequence. That is where most of the stars are going to live, or be born, live, and die. Now, because of the way this is set up, right, your hot stuff is going to be over towards the left. Your cold stuff is over towards your right. Now, up and down, right, is bright or dull, if you will. So, well, faint, I guess. At the top, you're going to be bright. At the bottom, you're going to be faint. And so if you're at the top left, you're going to be bright and hot. Bottom right, you're going to be faint and cold. And again, this is just pointing out that these axes are not linear. They're exponential, factors of 10. All right, so again, the blacked out line, that's your main sequence. Your lower right, so you're cold and faint. Those are going to be kind of red or M-type stars. Upper left, bright and blue, your O-type stars. Now, what's also interesting is these dashed lines that you can see. That actually gives you the radius. So now this diagram not only gives you the brightness, the luminosity, and the temperature, i.e. color, but it gives you radius. That's pretty impressive. So again, this gives us temperature, color, right, same thing, luminosity, absolute brightness, again, same thing, and radius. Just this one graph. And again, depending on where you're seeing it plot, it's going to give you a lot of information about it. So upper left, blue giants, blue supergiants, the hottest, the largest, the brightest, etc. Lower right, you're going to get red dwarfs, coldest, smallest, faintest. That's a picture from, it's old now, but an old British show called Red Dwarf. And yeah, they were not the sharpest tools in the shed, so coldest, smallest, faintest kind of fits. And then right at number 1, luminosity of 1 solar unit, is the sun. And it sits right along the main sequence. Alright, so for this diagram, they chose to just plot a different group, right? So you can see kind of red giants, the cold but large luminosity, blue giants, hot and large luminosity, and then they did kind of the upper part of the main sequence. Well, those blue giants are actually very rare. There's not many of those in the universe. What is popular is they did not show for some reason on this one, the red dwarfs. Red dwarfs are actually the most common star in the universe. 80% of the stars are red dwarfs. Now, red dwarf, if you remember in chapter 3, I believe I showed a picture or a video of a toaster, and then there was some guy yelling at the toaster. That was from red dwarf. And so the next slide, you can watch or not. It's an extended version of the theme song for Red Dwarf. It's kind of fun to watch in class. I don't know if you want to watch it while you're online or not, but it's up to you. No kind of atmosphere, I'm all alone. More or less, let me fly far away from here. Fun, fun, fun. In the sun, sun, sun. I want to lie shipwrecked and comatose, drinking fresh mango juice. Goldfish shows, nibbling at my toes. Fun, fun, fun. In the sun, sun, sun. Fun, fun, fun. In the sun, sun, sun. Okay, so there's the blue giants, the red dwarfs, and then there's another region called the white dwarfs. And we've already touched on this because we talked about Cirrus B, but this is where they would plot, right? White, so hot, and dwarf, so small. I like this version of the chart because every other version they kind of like charted it off for you. Like here's a circle of this, and here's a circle of that, and here's the way the main sequence runs. This looks like the raw data. Like if you were to take a bunch of stars and just plot them on here, this is what you would get. And you can see the main sequence developing here. No, they didn't plot many red dwarfs, but you can see the main sequence. You can see where the sun, then you can see this offshoot, and so you can, that's where the red giants are being plotted. So they're starting into the red giants. It's just kind of interesting. So Aldebaran, we talked about that one. That would be in there, 4,000 degrees Kelvin. So again, red, but a large star, large. Betelgeuse is up there too. Okay. Now what's interesting is I did say that red dwarfs were the most common star. And then this slide, you're like, well, wait a second, 90% of the stars are on the main sequence. Well, yes, the red dwarfs are part of the main sequence. They're that bottom corner there. Okay, now the white dwarfs, which we saw were the other bottom corner, that's only 9%. And then the red giants are 1% of stars. So you can kind of see, well, 91 and 1, that's, or sorry, 99 and 1, that makes 100. So what about those blue giants? Well, that's how rare they are. Right? Very, very rare.